E. coli multidrug transporter AcrB, transport mechanism. 3 protomers of this AcrB structure in red, blue and green represent 3 different states of the transport cycle. The major structural change is observed in the pore domain, and extracellular, membrane proximal domain. For the access protomer in green, the vestibule is open at the side to the paraplasm for substrate uptake. For the binding protomer in red, the substrate binding site has changed from that of the access protomer. The substrate binding site is at the distal end of the vestibule, close to the top of the pore domain. For the extrusion protomer in blue, the vestibule is shut with no room for substrate binding. An exit is open to the TAL-C binding domain and to the DOL-C. Substrates bind to the distant end of the hydrophobic pocket of the binding protomer. PN1 in red and PC2 in cyan have moved away from PN2 in yellow and PC1 in green to expand the binding pocket. The gap between PN1 in red, PC2 in cyan and PN2 in yellow and PC1 in green is closed for the extrusion protomer to eject the bound molecule through the TOL-C channel. The central helix of the extrusion protomer in blue is inclined toward the binding protomer in red. The movement opens the exit pathway of the extrusion protomer between the PN1 in red and PN2 in yellow. At the same time, the same central helix in blue closes the exit pathway of the binding protomer in red. Some bulky substrates bind to the proximal pockets of the access protomer between PC1 in green and PC2 in cyan. The binding site is different from the binding site of the binding protomer, which is located between PN1 in red and PN2 in green. The proximal and distal binding sites are partitioned by the Fe 617 loop in magenta, which swings to send the substrate to the distal site as observed in the binding protomer in red. A helix connecting the PC2 and TM8 allow the movement of the subdomain. The helix unwinds for the access protomer in green, rewinds for the extrusion protomer in blue.